Recently, I played Uncharted: The Lost Legacy, and it was absolutely beautiful. Any gamers out there, please try it at least once. It's absolutely beautiful game. Apart from that, I work at Grow as a mobile engineer, and mostly I do performance there, improving the performance. And I created one job around for myself by creating a library. That's what I'm going to talk about today. So today I'm going to talk about creating an in-house library to measure performance in mobile apps. So we are going to talk about 5 things here. First, why we wanted a performance measuring library at the very first place. Next, what were the key metrics which we are looking to measure. Then, why we created our own library. And I will also provide some implementation detail of our library. And the last and the most important part, that how did it impacted our organization. Because no matter how cool your code is, if it doesn't serve the purpose, then it's useless. Now, so why we wanted a performance library, right? So these were some of the users' complaints which we used to get, that your app is slow. It takes time to navigate from page A to page B. But क्या करें हम इसका? Like, क्या करूँ मैं इस चीज़ का? Because here's the thing. An app could be slow because of many reasons, right? And there are no things provided in a complaint. It's a complaint, right? It says you कि ये कचरा है, correct? So as a mobile developer, what should we do? Because an app could be slow because of many reasons. A user could be using your app on a very low end internet, or they might be having a low end device as well. Or our backend APIs could be responding slow, which they will never agree. So what should we do next? So our team did a lot of efforts to improve the performance, but all of them were in intuition and some trace from Perfecto, but we could never see that what the changes we are doing at, whether it's making an impact for a large variety of devices or not, correct? We couldn't see it because we didn't have any data to work on. That's why we decided to have our own performance library, that we want to collect some data and we want to improve on the same. So what are the key metrics which we were looking to measure? So we were looking to measure primarily 2 metrics here. One was TTP, second was TTI. So TTP is nothing, just it defines at what point of time your screen was painted. TTI is at what point of time it became interactive to users. Alongside this, we also wanted an ability where we can measure custom measurements as well, because we have graphs in our app and many other things. We wanted to measure all of them. So we wanted to have some custom measurements in place as well. So these are some of the existing solutions to measure performance in React Native apps. One is by Shopify. It's Shopify React Native Performance. About Pros, it has a very beautiful API design, really beautiful. It makes super easy to measure TTP and TTI. Next, it provides you native render timestamps, so which means you have exact time at what point of time your element was painted at the host platform, not on JS. Next, you can collect that data and throw at your own analytics service or whatever you want. It gives you a whole JSON report which you can consume to any analytics service. About cons, just one, that it only focuses on TTP and TTI, and it doesn't provide an API to collect some custom measurements. Next is by React Native Firebase Perf. About Pros, that it is a very low-level API. So it gives you granular control over the API. And Firebase Performance Dashboards provides you a good set of filters. About cons, the API is unintuitive for the React world. That's our opinion, by the way. We didn't find the API quite intuitive for our React-ish world. So we wanted a mix of them. So we wanted a solution which focuses on TTP and TTI majorly. Alongside, it should also be able to collect custom measurements, as I said before. So we decided to create our own abstraction on top of Firebase Performance, because our company was already using Firebase for a lot of other things. So it also was about an ecosystem as well, as all the PMs and everyone they knew the platform already. Now, to understand our implementation detail, it's very important to understand that what's Firebase Perf do and what's the terminology around it. So about the terminology, it provides you two major things. First is trace. Now, a trace is nothing, you can measure anything for an action. Now, action could be anything. It doesn't depend on a UI action or anything. It could be anything. It could be like scroll events or anything. Okay, so it measures a time frame you can consider. Next is metrics. Now, metrics are custom events recorded for the ongoing trace. Okay. Now, for our abstraction, we don't have anything as metrics. What we do have is spans. Now, for spans are nothing, just a unit of time for the ongoing trace. For better visualization, you can see this. Is a trace is a time frame. Inside it, we have unit of times, which are spans. Okay? So, I'm giving you a small example on how we measure TTP and TTI of our screens. So, we have I hope the code is visible. So, it's a very common pattern which we have, that we have a hook which returns the data and a loading state. Based on the loading state, we render a loading indicator or the main content. So what we do is, first we import performance measure container from our library and create trace screen. We wrap our screen with performance measure container and pass interactive prop, which would basically define that at what point of time your screen had become interactive to users. Now, if you look closely to it, that API is very much inspired from Shopify's library, thanks to them to making a very intuitive API design. And performance measure container will also calculate the TTP within it. We don't need to calculate manually. Next, we will export our screen with create trace screen. We will pass our component and also the name of our trace. Behind the scene, it will create a context and drill down the trace instance, which will be consumed by the React tree. So, a little example on how we add some custom spans to our code. First, we import useScreen trace. Next, we get some methods out of it, which are start span, and stop trace. Next, we will start a span, which is like fetch latest Pokemon. I want to measure that how much time it would take to fire this function and get the result. Next, I will do the function here, the heavy task. Next, I will stop my span. I will also stop my trace. This is how our data will look like on the dashboard. We have TTI in place, we have TTP, and fetch latest Pokemon, which, as I showed you here, the span which I had added. This is how it will look on our dashboard. Next, if you see closely that our API didn't add any async await to it, right? It didn't have any async await. Sorry, it didn't have async await. But in React Native, everything is asynchronous, right? Because we are communicating to the host platform, and there is no way we can do it synchronously, right? So the reason why we have a synchronous like API to devs, because we think of a performance measuring library as a very silent operations. If we are collecting operation, then it should be very silent. Because if we have await to our measurements, then we will add a slight delay to our main code, which we didn't wanted. Fun fact, the talk was actually previously titled Going Synchronous in an Async World. Sorry. Now, behind the scenes, by the way, we have a trace class which exposed the method which we now saw just now. Start trace is a app performance measure. Sorry. So behind the scenes, it's still a promise. But the thing which we have done here is that we have made the API in a fire and forget mention. Behind the scene, it still calls a promise. For the stop trace, we stop the trace, and we also send the collected span data to host platform. Now, because of this, we don't communicate to native layer that much, because as you all know that communicating to host platform is very costly in RN. So we communicate to that layer only twice. One, when we start the trace. Second, when we stop it and also flush our collected data. But how we are able to do this? So if you observe this API behavior closely, we start a trace, we collect some data, then we stop it. Which means a trace will start first, then it will collect the data, and it will stop. Now this whole flow is very predictive, right? That means this all can be derived with states. That's what we do behind the scenes. We maintain states of our promises, and we can easily derive at what state that trace is currently on. Now about the impact, right? How did it impact these measurements? How did it impact our organization? So first, we finally started getting some meaningful data to work on. Previously, we had nothing. We had just user complaints that your app is slow. We started getting these meaningful data on which we could finally work on. Second, stakeholders started analyzing this data, and if they found any regression, they would prioritize it, and our engineers were able to fix it very early. Then, as soon as we started working on these measurements and as we improved it, we started seeing few user complaints, few user drops. So overall, it impacted our business as well in a positive way. Now, a big win for us was this. So last year, our app went to a whole new UI revamp. This, on the left, we have the old UI. On the next, we have the current UI. Now, between these, we had lot of changes about the number of API calls we are making, the API contract, and some new screens as well. So primarily goal was that as we are launching a new UI to users, it should not introduce any performance regression to them. That's why we were actively tracking on our measurements whether we are hurting them or not. With these things, we were finally able to launch our new UI without introducing any performance regression, because we caught it early and we acted upon it very much early. Now about the closing note. So with time, we will surely create a better library. We will have a bigger scale to work on, and we will outgrow this solution as well. But however, this library has already fulfilled its purpose. It has given us very much meaningful data on which we were able to improve on. And overall, it provided us a very beneficial impact. Now, last but not the least, don't fall in love with the code you write. Fall in love with the impact it can bring. On that high note, bye. If you have any doubts, connect with me.